All right, so as you know, every week we get at least one announcement, if not many, many more from me. So I just wanted to remind us that we should be checking our Canvas and our email to be reading over the La Semana and any other reminders. So I'll let you read through this on your own time, blah, 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 blah. This one is especially large because I want you to pay special attention to this. So folks, that final exam is optional, okay? So as we sort of get into the routine of the semester, sometimes it's good to think about the carrot, so to speak, at the to kind of keep us motivated here. But the final exam is optional for folks. So if you didn't do so well on exam one, or you have a bad day on one of the exam days, you can have the final exam replace your lowest exam grade. I do want to clarify, though, this is a privilege that you can lose. People have lost it in the past. So if you are frequently not present in class, or you're skipping assignments, or you're submitting incomplete assignments, then you, my friend, are getting dangerously close to that idea of that final exam not being an option for you. I would hate for that to be the case. So I encourage you to make sure that your assignments are complete, that you are doing what you need to do, so that that can be an option if you want. All right, a couple reminders for week 5 announcements. So we've shifted the schedule a little bit. So I've updated the schedule on Canvas, which I'll show you where you can find that again. But please read over these deadlines. I noticed that sometimes when I post the announcement, if I make edits to it afterwards, I don't think that Canvas sends you another announcement. So going directly to Canvas is probably your best bet in terms of making sure you have the most updated announcement, okay? This week's quiz is going to be pretty long, and as such, the quiz deadline is actually Sunday at midnight rather than Friday at midnight, okay? There is no math and writing assignment this week, but the next one will be due in 2 weeks. All right, a couple of things about the support. So if you are interested in the tutoring sessions, okay, the tutoring session location where you go through the interweb is a little bit different this week. So if you have been going to tutoring and you've been used to going to the STEM center and checking in and then going to the specific tutor, this week you're actually going to go directly to Isam's room. Okay, so the link is here if you want to go ahead and access that room, or you can just click the link, should bring you to his Zoom room. This week, he is offering 2 sessions, Tuesday from 1 to 3 and Thursday from 9 to 11, okay? I know for the folks that have been attending, it seems to be serving them quite well. I would say that of the folks who are attending versus not attending, the folks who are going to tutoring currently have a significantly higher average than folks who are not going to tutoring. So think about that for a moment. I know those office hours don't work for everyone. However, we also have office hours, and there are other resources for 150. You can go to the STEM center and still find a tutor. Okay, so if your hours don't really allow for our in-class tutor, then maybe you start to seek some outside resources as well. Office hours for me this week are Wednesday and Friday from 9 to 9:30. So we're going to try the Friday thing, see how that goes. I think especially with this week, with the quiz not being due until Sunday at midnight, that hopefully will give you a little bit more support going into the weekend. But I do want to point something out. If you're going to show up on Friday, I do expect that you have looked over the quiz. So don't show up on Friday and be like, I didn't really look at it yet. Then I don't really know why you're there. Okay, so I love to chat with people, get to know you, definitely an option. But if you're going to show up to office hours, then come with some questions. All right, do yourself a favor, look over the quiz before you show up and come in with some questions. Last but not least, if you've not joined that Desmos class, that is the easiest way to make sure that your work gets saved, that you don't have to submit anything, like you don't have to take pictures of your Desmos as you go through. It will be saved for you, and I'll be able to refer back to that. And you should be able to go back to your activities as well. Okay, so this is probably the best way to stay organized in Desmos. All right, last but not least, if we go to the home screen, then we can see the course schedule. Okay, so let me just make this a little bit larger. Okay, so there is a course schedule. This is a Google Doc, which means it is live. Okay, and what that means is as we make adjustments or we finish things, I modify it on here. Okay. So if you printed this out at the beginning of the semester and you're like, oh, she's going to stick to this every single day, you were sorely mistaken. This is a very interactive experience. Sometimes we move a little bit further ahead. Sometimes we fall a little bit behind. But week 5, this is where we're at right now. So what we're covering this week is we're finishing 3.3 part 2. We're taking a look at particle motion. And there is the derivatives of trig functions. Okay. Now, in the La Semana, I also pointed out there were 2 activities on Desmos for you this week. Are these mandatory activities or not? I see one person who says no. I ask you to modify that sentence. Ooh, yes, no, maybe so. I don't know. Let's go back, read the La Semana. I'm telling you, there are 2 Desmos activities. You figure out which ones are mandatory. It should be in the announcements, okay? Another thing I want to put on your radar is that this week and next week and a tiny bit into that 3rd week, that's where we're going to be finishing chapter 3. Your next chapter test, exam 2, will be on Friday, March 19th. Okay. So it's not the Friday right before spring break, but it is the week before that. All right. I will be posting next week a topic list so you can start to study. And there is also going to be an optional assignment on WebAssign that you can do just to review. It has a whole bunch of practice problems that I dumped in there for you to kind of take a look at. Okay. So if you're not regularly checking Canvas or you're not regularly checking the course schedule, I would encourage you to do so. I think it helps stay a little bit more organized, at least for me it does. So hopefully it does for you as well. All right, I'm going to stop sharing my screen there. If you have any questions about the La Semana or the course schedule, please ask me after break. I'd be happy to answer some questions, or you can always shoot me a separate email. But for right now, we're going to jump right back into 3.3 part 2. Okay. So let me go ahead and share my screen. There we go. Awesome. Thank you, Natalia, for checking. Folks, if you have not read the chat for the answer to the previous question about what is mandatory and what is not, please read the chat. All right, so here we go. Let's remind ourselves, because it's Monday, Wednesday was so long ago, that when we finished class on Wednesday last week, we were looking at product rule and quotient rule and really practicing decision making and thinking about, well, what if we strip away the numbers completely or the expressions, the equations, and we just have numbers, what does that look like? And how do we think about those kinds of problems? Same idea again with example 3. We were looking at what rule are they trying to get us to do, and when are we allowed to substitute in values and when are we not? And then we took a final look at what it looks like when we're thinking about these same ideas of slope and y values, but on a graph. Okay. Now, I know that these were big concepts for us. And so in looking over quiz 4, I would really encourage some of us to maybe just ask those questions at office hours or at tutoring, clarification. Even if the quiz is passed, you are still in your full right to ask for clarification, okay? But for right now, we're going to move on to higher order derivatives, okay? And so some of us have already kind of thought about this concept, especially if we were able to make tutoring. I think there was a pretty good conversation about the fact that we can take derivatives more than one time, okay? And so the question I want us to think about here is, if the derivative tells us about the steepness of an equation, or like the slope of an equation, what do you think a second derivative tells us? Okay. Take a moment, marinate on that for a little bit. What do you think that second derivative tells us? And what about that third derivative? Okay, so maybe the slope of the first derivative. So maybe that second derivative is the slope of the first derivative. Okay. Wonder if you can clarify that, how low it can get. What do you mean by how low it can get? So if the first derivative is already a line, how do you get a different slope? Okay. Well, so far, Natalia, that is how we take a derivative, okay? But I do want to make a point really clear here. We don't always take a derivative by subtracting 1 from the exponent. Okay, so we do when we can use power rule. Okay, so when we use power rule, that's how we take the derivative. But when we have product rule, that's not how we take the derivative, right? We have to like set up our u and our v and our du and our dv. And we're going to learn a lot of other methods too. So I don't want us to be stuck only on derivative being subtracting 1, okay? More precise. What do we mean by that? What do we mean by more precise? Are you saying that the third derivative is more precise than the second derivative? Okay. So it's not necessarily about getting more accurate. Okay, so it's not in the sense that if you are looking to get like a better answer, then you do the process again. Okay, I can see though where you might get that idea. I think that's a pretty good idea, but in this case, it's not applicable. Okay. It gets closer to horizontal. Okay. I hear someone saying something about concavity. Okay. Well, let's kind of keep this question in mind as we sort of go through the process, okay? Because what we're going to do today is sort of practice the process. But when we get into 3.4, we're really going to be looking at the meaning of that second derivative or the third derivative or the fourth derivative. And so it's important to kind of think we have these process or this procedure that we're doing, right? We have these procedures, but we also have an idea underneath these procedures that we really need to focus on, okay? So rate of change. So I'm hearing a lot of good terms, rate of change, positive or negative. But one thing that I think we're really going to try and grow in this semester is thinking about being really precise with our language. So tell if what's positive or negative, right? What do you mean by the rate of change? I thought the first derivative was the rate of change. So how is that different for the second derivative? How is that different for the third derivative? Okay. Let's kind of table this conversation for right now. Let's go back into some procedure, okay? I think for some of us, it makes us feel better when we can solve a problem. So let's solve a problem and see what we get. All right, so example 5, okay? We've got this function y equals 3x squared plus 8 square root of x minus 10. Now we look at these questions, it says find y prime. Part B says find y double prime. And part C says find y triple prime, okay? Now some people say it like y prime prime instead of y double prime. It doesn't really matter, okay? But each little mark tells you to take a derivative. So if you have 1 mark, you take the first derivative. You have 2 marks, you take the second derivative. 3 marks, we take the third derivative, okay? Now, before we actually take the derivative, let's rewrite this y equation. And we want to rewrite it in a way that we know which rules we're going to be using. Okay, so let's take this term by term. 3x squared, good to go, or do I need to rewrite it? So 3x squared, are we okay? Yeah, we're good to go. 3x squared. Okay, what about this 8 square root x? Can I just take a derivative of that? Rewrite. Okay, and what is that going to look like when we rewrite it? 8x to the 1/2. I love it. Minus, what about 10? We good to go? I think we're good to go. Okay. All right. I'm making this step really explicit because I think a lot of times we rush over that. We're like, I don't want to rewrite it. And then some of us on the quiz, we were using quotient rule and our answer was so long, so many steps. It's not always worse to have more steps, but sometimes when we rewrite, we save ourselves some more time, okay? So if we take our derivative, we're gonna get 3 times 2x to the 2 minus 1 plus 8 times 1/2 x to the 1/2 minus 1 minus 0. Any questions? Sorry. Any questions on this process right here about that power rule? Okay. At this point, I'm going to start not writing out all of these steps, okay? Meaning I might look at 3x squared and say that derivative is 6x. Okay, and I might not write out 3 times 2x to the 2 minus 1. Okay. I might still write when I have like a constant like 10, I might still continue to write that 0, but at some point in the semester, we're not going to continue to write that. Okay. So it's not like a, threat or anything like, well, now we don't need to show the work. I just want us to be aware that like, we want to make sure that this is something that we can sort of do a little bit quickly in our heads. And so if we're not there yet, we just need to practice that a little bit more. Okay. That second term, I think we'll still need to write out a little bit. So 8 times 1/2 gives me 4. X to the 1/2 minus 1 is negative 1/2. Great. And if this were my final answer, like I wanted to write a final answer, I might write 6x plus 4 over square root of x. Okay. All right. Now to find y prime prime, or the second derivative. All right, hang on 1 second. Let's try this again. Okay, hopefully this should be a little smoother. Okay. All right, so to find the second derivative, my question to you is the answer in the box a better starting place, or is this a better starting place? Which one do you think will be easier for you to find the second derivative with? Yeah, the non-boxed one, or as Antonio said, the one with the power of the negative 1/2, right? So this one right here, like sort of the unsimplified version, that's actually a nicer version to keep taking derivatives of, okay? And so we're gonna take this line right here, and we're gonna go ahead and find the second derivative. Now, all we know is power rule so far, okay? Power rule, product rule, quotient rule. And so there's not a ton of decision making here, okay? Now, when I take that derivative of 6x, I'm gonna get 6 times 1x to the 1 minus 1, plus the derivative of the second one is 4 times negative 1/2 x to the negative 1/2 minus 1. And so we'll get y prime prime equals 6 minus 2x to the negative 3/2. And when we go ahead and rewrite this to make it a little bit nicer looking, y prime prime equals 6 minus 2 over x cubed and the square root of that. Okay. All right, questions so far, folks, questions so far. We took the first derivative, we took the second derivative. All right. I'll give you folks a couple minutes to work through the third derivative, okay? So we have our second derivative. And I want you to go ahead and find the third derivative. Yes, David, that is correct. Take the first one and you do the derivative again. Okay. I'll give you another minute or two to finish up part C. All right. So folks, when we start and we take that derivative, I hope that we decided, oh, this version, the one that's not boxed, is probably the better one to work with because it's already rewritten for us. Okay. So can someone maybe help me out? What is the derivative of the 6? What do we get for the 6? 6 becomes a 0. Okay. Minus 2. All right, bring that power down. Negative 3 halves, x to the negative 3 halves minus 1. Good, nice. Okay. And so we'll get y triple prime equals 3x to the negative 5 halves. Or if we were going to write that as a radical and without negative exponents, we would get 3 over. Now I know there's a radical, but can someone tell me that power of like the 5 here? The numerator, that 5, does that go inside the root or on the outside of the square root symbol? Yeah, so we get x to the 5th. And then how come I don't have to write anything here? Yeah, it's a square root, okay? So it's one of those like imaginary, I gotta say that, not imaginary, it's an implied number, thank you. All right, it is implied that there is a 2 here. It is implied that there is a 2 here. It is implied that there is a 2 here, okay? All right, so the procedure of finding a first derivative, second derivative, third derivative, okay? So we could keep going. We could find a 4th derivative, a 5th derivative, a 100th derivative, okay? But the process is exactly like David sort of summarized in the chat earlier. He said, so basically we take a derivative and then we do it again, all right? And that's exactly what we're doing. We find that first derivative, then we can find the second one. Then we can find the third one, okay? Exactly, that negative here, let me go ahead and, this negative means that this is in the denominator of our fraction, okay? I know, it's like so many little rules that we're like, we learned once upon a time and we just kind of gotta be able to go with right now, okay? Actually, that's a really good question though. What is the power of 3? So I have 3x to the negative 5 halves. What is the power of 3? Yeah. So if it helps you to write in that exponent as a 1, go ahead and do that. Because I think everybody knows that 1 is not negative. So that's why the 3 stays on the top. It doesn't have to move to the bottom. Okay. Yeah, exactly, Ethan. I think that's a really great, simple example to help you remember that rule. Okay. All right, so there is a question like this on your quiz for this week, okay? Being able to find that first, second, and third derivative. So make sure that that's a skill that you feel comfortable with, all right? All right. And let's move on to another application of slopes, okay? And so we think a lot about derivatives. And by now, I think we've really connected that idea of derivative to slope, okay? So now, one of the things that we like to sort of be able to find in math is moments where there are special slopes, okay? So let's think back to like very basic ideas of slope, all right? And think about what it might look like. So let's start over here. What does it mean for a line to have a slope that is horizontal? And what does it mean to have a line that has a slope that is vertical? Okay. So just type in the chat whatever you think you have to contribute to that idea. All right. What is true about a horizontal slope? What's true about a vertical slope? Okay. So the horizontal line has a slope equal to 0. I agree with that. And what that means, the slope being 0, also means that the derivative equals 0. Okay. And so this is such an important concept. Maybe let me just put that in the middle of the box, make it a little bit bigger, that when we have the slope is 0, that means the derivative is 0. And that only happens when we have a horizontal line, okay? So if someone says, hey, I want you to find out where this function has a horizontal tangent line, they might be asking you, hey, find out when that derivative is 0, okay? Now, I love what people have said about the vertical. So a slope of a vertical line is undefined, okay? And what that means is that the derivative is also undefined, okay? So having a slope that is undefined also means having a derivative that's undefined, okay? When do we kind of have values of numbers that are undefined? Like, can someone give me an example of an equation where if I plug in a number, it will be undefined? Oh, okay. So 213121, if I divide that by 0, is that okay? All right, and I hope our answer is that this is not okay to divide by 0, okay? So when we're dividing by 0, that is not okay. Meaning zeros on the bottom is a problem, okay? All right, what does it mean for two lines to be parallel versus perpendicular? Tell me what it means about their slopes. Okay, so parallel means that the slope of line 1 equals the slope of line 2. Okay. And what does it mean to be perpendicular? Perpendicular is not inverse. Okay, we got to be really precise about our language here. Perpendicular does not mean inverse. Perpendicular means they meet at 90 degrees. I buy that. So parallel might be something like this, whereas perpendicular might be something like this. Where they meet at 90 degrees. All right, but way back in middle school, there was a rule that folks learned about slopes of perpendicular lines. What is that rule? Oh, dig back in that brain. What is that rule about the slopes of parallel lines? Oh, we've got pieces of it. We've got pieces of it. All right, we're looking for the slopes. Be more specific and then opposite reciprocals. There's a lot of sort of opposite and switching of things. What do you mean by opposite? Okay, maybe some examples, right? So 1/2 and -2/1. Okay, I believe that that would be slopes of lines that are perpendicular. Let's get the language right though. It's not an inverse reciprocal. What is a reciprocal? I know there's so much language, right? This is hard, but I want us to get it. What is a reciprocal? Let's maybe start there. Okay, so reciprocal is 1/2 or 2/1. Okay, so how would we describe that to someone? A flip? Let's be a little bit more specific. Okay, so they do multiply together to equal 1, all right? But how would we maybe summarize that process for someone? Okay, so maybe let's take Natalia's statement and Yithan's statement and combine them, that we're flipping the numerator and the denominator, right? So we are switching the numerator and denominator. And like Moon said, when we multiply them, they should give us 1, okay? So a pair of reciprocals multiply to make 1. Okay. Now let's get that other piece though, because 1/2 and -2/1 are not just reciprocals, right? And I think someone said it earlier in the chat, they are in fact negative reciprocals, all right? So when we're thinking about perpendicular line, we want to think negative reciprocals, okay? What gets really tricky when people say opposite, you can say opposite, but I would say opposite sign reciprocal. Because when you say opposite, some people think, oh, flip, and then they just think reciprocal. Okay, so I know that's kind of a small point, but I really want us to be careful about this language there. There's a lot of different inverses. So that would be maybe a different question for a different time, okay? But I would maybe read up on what inverses are. Yeah, they're not the same as a reciprocal, okay? All right. So before we move on, a horizontal line has a slope of 0. A vertical line has a slope of undefined. Parallel lines have the same slope, while perpendicular lines, they have opposite signs and they are reciprocals of each other. Okay, so opposite signs and reciprocals. All right. Why do we need to know what those things are? Well, they help us answer questions that kind of look like this. Okay. So remember, these questions are calculus questions. However, the bigger part of them is that we got to have some background coming into it. Like, what does it mean to be horizontal? What does it mean to be perpendicular? Things like that, okay? So example 6 says, find the x-coordinate of all points on the graph. And here's our graph. Y equals x cubed plus 2x squared minus 4x plus 6. So we're finding x values where the tangent line is horizontal, okay? Where the tangent line is horizontal. What kind of slope do we think we're looking for here? What kind of slope are we looking for? Okay. So I would make a note for myself right here. Slope equals 0. I see horizontal, I think slope equals 0. Okay. How do I connect slope of 0 to this graph and the ideas we've been talking about in calculus? Okay. So if we're looking for the slope equals 0, what we're really saying is set y prime equal to 0, right? Because slope is the same as first derivative. That's the secret to these kinds of questions, okay? I didn't say find the derivative, set it equal to 0, and then solve for x. But underneath all of these words, that's exactly what I'm saying we should do, okay? So our first step here, we're gonna go ahead and find y prime, okay? So y prime equals 3x squared plus 4x minus 4 plus a 0, so I'm not gonna write it. Right? So pretty straightforward here. Use that power rule, find your derivative. Now we're gonna set y prime equal to 0. So we'll get 0 equals 3x squared plus 4x minus 4. Okay. To find the x coordinates, we now have to solve for x. Okay. I'll give you a moment to factor that expression. All right, if it is a factorable expression, we are factoring. We are not using quadratic formula. Ethan, a min and max is not necessarily, yeah, it could be a min and max. It doesn't always have to be the vertex. The vertex kind of means different things in different places. It's one of those annoying things. Okay. All right, so this should, and double check my work, I think this should factor into 3x minus 2 and x plus 2. Does that work out? Yes, okay. All right, and then that means we can solve for x by having 3x minus 2 equals 0, or x plus 2 equals 0. And we'll get x equals 2/3, x equals -2. And so now we have the two x values, -2 and 2/3, where there is a horizontal slope at those 2 points. Okay. Yes, extrema, exactly, yeah. Could think about them like extrema. All right. Let's go ahead and take a look at question number 7 here. So slightly different flavor of question, all right? So question 7 says, hey, here's this function, x equals, or y equals x to the 5/3 plus x to the 1/3. This time, I want to find the x coordinate of all points on the graph. Ooh. That are perpendicular to this line. Okay. And then later on in part B, I want us to find the x coordinate of all the points of the graph that are parallel to that line. Before we start computing, what might be our overarching process? Okay, so before we start like plugging numbers in and doing that, are we finding a derivative? Are we setting it equal to 0? What are we doing here? Are we stuck? What's going on here? Help me out a little bit. We're stuck. Okay. So what does it mean for a line to be perpendicular? What does it mean for a line to be parallel? Let's start there. All right, so we've got perpendicular, we've got parallel. What does that mean about slope? Okay, so that means that this will be the negative reciprocal. Negative reciprocal, and then this one will be the same slope. Okay, so same slope as what? Negative reciprocal slope compared to what? Compared to 2y plus x equals 7. Yes, okay, there we go, right? So I don't care about the rest of it yet. Let's just kind of focus on this piece right here, right? That's as close to what we kind of hinted at earlier. And then same thing, let's kind of look at this as the same slope compared to that, okay? All right, well, maybe in order to give these things some numbers, we should find the slope of that line. All right, that seems to be a good place to start. What is the slope of 2y plus x equals 7? Got a -1/2. Okay, my guess is folks are solving for y. That seems to be a reasonable strategy. So 2y equals -x plus 7. Y equals -1/2 x plus 7/2. Okay. Okay. So we've got a slope, and specifically we have a slope of -1/2. So what do we want the slope of the parallel line to be in part B? Okay, that means that this slope should be -1/2, right? No, you were right. I was asking about part B. Part B is -1/2 because it's got to have the same slope as the line we're comparing it to, right? But jumping the gun a little bit there, folks have got 2 because that means that this negative reciprocal slope should be 2 because 2 is the negative reciprocal of -1/2. Okay, so let's pause for a moment. Are we okay with how we found 2 and -1/2? Are we okay with how we found 2 and -1/2? We've got 2 yeses. Any other yeses? 3 yeses? That's good enough. The rest of you don't matter. I'm just kidding. Okay, how did we find 2? All right, someone help us out here. How did we get 2? In particular, this 2. Does that answer that question? Yeah, yep, negative reciprocal. Now here's the deal. One of the reasons I hate when people say negative reciprocal, even now it's like in our notes, is that sometimes we think that answer always has to be negative, but when we say negative, we're really saying change the sign, change the sign. Exactly. Since the slope is negative reciprocal, the negative of a negative is a positive. Okay, so maybe let's go back up and modify this a little bit in the sense that you might hear this phrase negative reciprocal, but maybe what works out for us better is opposite sign. Reciprocal, all right? It's not as catchy as negative reciprocal, but maybe that clarifies that point where it just has to be the opposite sign. And we have to switch the numerator and the denominator, okay? All right, great question and great support by folks in the class there. All right, so we've got a slope of 2 and we've got a slope of -1/2. All right, now the question really becomes for part A, find the x values of this function that have a slope of 2. How do I bring in derivatives? How can we change that question now to be something about derivative? right? How do we find out when the slope is 2 or when the slope is negative 1/2? Right, I see one idea in the chat that says y prime equals 2 and y prime equals not 1/2, negative 1/2. Ah, okay. So in the chat, someone said maybe we equal them to each other since they're both equal to y. And I think that I've seen that before. I've seen people do that, okay? But the key word here is really that we're looking for a slope of 2. What word can we replace slope with? Okay, so instead of saying find all the points with a slope of 2, what we're really saying is find all x values where the derivative is 2. Okay. So this question, part A, is really saying find all x values where the derivative is 2. Where did we get derivative from? Okay, we got derivative from slope. So maybe let's underline that. We got derivative from slope. Where did we get the slope from? Exactly. We're looking for the tangent of the graph. And more specifically, we were looking for a slope of 2 because it was perpendicular to a line that we already had. Okay. So anytime someone is asking you about slope, parallel, perpendicular, horizontal, vertical, anytime someone's asking you about slope, they are really asking for you to use derivatives. Okay. That is such a big concept. I want to say that one more time. Anytime someone is asking you about slope, parallel, perpendicular, horizontal, vertical, anytime someone's asking you about slope, we want to be thinking, oh, I got to use a derivative. Okay. So slope, derivative, derivative, slope. So let's solve that. Y prime equals 2. What do you mean by it? The slope is 2. Yeah. We're looking for where the slope is 2. All right. Now that means we got to find the derivative. We got to take our original function. We got to find the derivative. So we're going to get 2 equals 5/3 x to the 2/3 plus 1/3 x to the negative 2/3. Okay. If I take this equation and I multiply everything by 3, I'm going to get 6 equals 5x to the 2/3 plus x to the negative 2/3. And turns out that I can use some algebra And eventually I get x equals 1/5 to the 3/2 and x equals 1. Okay. I'm less concerned about over the top tricky algebra like in this particular problem. I'm more concerned that you can explain to me the process of how we find these things. Okay. So let's not necessarily solve part B, but let's write out in words what this question is really asking, but also think about like a process, like where are we going to start? Okay. So if I were to think about this question, find the x coordinate of all points of the graph that are parallel to the line 2y plus x equals 7. No, that's not an answer. There's like 20 steps that happen in between there. It's only like if your answer needs to be x equals a number. If you don't have x equals, then it's not giving you the x values, right? Yeah. Okay. So if I were to think about this in terms of a process, the first thing I would do is find the derivative. Okay, so I'd leave you to find that derivative. Once you have that derivative, okay, let's kind of go back up to question number 6 here. After we found y prime, we set y prime equal to 0. Do we always set y prime equal to 0? Okay, I see a no. We set y prime equal to 2 in part A. What do we set the derivative equal to in part B? Okay, equal -1/2. Okay, because that's the slope you're interested in. You want a slope of -1/2. Right? In part A, you want a slope of 2. So we're just changing that number piece, but we find the derivative, we set it equal to whatever number we are looking for, and then we solve for x. Okay. I know that doesn't give us an exact answer, but maybe even more powerfully, what it does give us is sort of a general process. And I just want to make a note that this number changes depending on what slope we are looking for. Okay, so that idea that this number changes depending on what slope we are looking for, that is a great way to talk through a problem with some friends. Okay, say right after class, you're going to start work on quiz number 5. You're going to find the question that looks like this. I would make a note to yourself. What is that number in step number 2? What number are you setting that derivative equal to? Okay, the rest of the steps are going to be the same. Find a derivative, set it equal to some number, solve for x. But how do you find the number you're supposed to set it equal to? That is a good place to have a discussion. Okay. All right, so folks, we're gonna take a quick break right here. So I'm gonna stop sharing my screen. Okay, we're just going to do one of these graphs. And the reason why we're just going to do one is because it is sort of the same idea as we go through all of these questions in terms of we're going to be looking for specific points. We're going to be using Desmos to create a graph, and we're going to be drawing some pictures and finding some values that go with the pictures, okay? So for the sake of computation, we're going to start with y equals x squared minus 4x plus 6. I think it's just a little bit nicer than the other graph that we have, okay? Now, I know you folks all know this is a parabola. You might be like, I don't know what's going on in calculus, but I know you know this is a parabola, right? So we'll go with the parabola. If you were to graph this on Desmos, you would end up with a parabola that is facing up or facing down. Yeah, it's facing up. And actually it has the vertex, or sort of the bottom of that is a weird looking parabola. Anyway, the bottom of this parabola is going to be in that first quadrant, okay? So we've got a picture kind of like this. You can graph that on Desmos later, just to double check, and you are welcome in the homework where it says use Desmos to graph it, and then just draw it up, whatever you have on your picture, okay? So now let's kind of think about this in terms of, I'm going to draw this again. Let's think about this in terms of like where values are on the parabola. So if I were using Desmos, one thing I might notice is that right at the vertex, it actually has a coordinate of 2, 2, okay? Now, for the sake of this problem, I don't expect you to find that by hand. If you're using Desmos to graph, you can certainly grab specific points from there, okay? But I think this point is relevant because in part B, it says find the slope of the function at x equals 1, okay? So if someone could annotate on my screen for me, can you draw the point on the parabola where x equals 1? Yeah, perfect, right? It's somewhere to the left of that vertex. And we might not know exactly where it is, but I think that that's a pretty good ballpark, right? That's sort of where everyone's points are about. Okay, great. So now if I want to find the slope of the function at x equals 1, do we expect our answer to be positive, negative, 0? Like, what do we expect that number to be? All right, I see a few votes for negative, and I believe you are correct. Because if we were sort of to sketch out the tangent line here, whoops, we might see something kind of like this. Okay. And so find the slope of the function at x equals 1, we imagine that our answer should be negative. Okay. That's a connection that you were able to make. That's awesome. All right. That's a really good place to be in terms of, you know, making sure your answer is sort of reasonable. Okay. So we've got this curve. We've got a point. We want to find the slope. What's our process? What tools can we draw upon? since it's tangent. Okay. Now, maybe before we sort of head down that path, okay, and I can see where you got that. Since it's tangent, we'll look at something parallel, because that's the last sort of flavor of question we were working on. But in this case, let's maybe back up a few steps. What do we know about slope in connection to all of the things that we've learned, and specifically slope at a single point? Right. I'm seeing someone say that the slope of the function at a point reminds them of the instantaneous rate of change formula. Okay. All right. And that formula is the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay. We could certainly do that. Right? That's a formula we know. We know that we use that when we're looking at the slope of a function at one single point. What is a faster way to get to that same idea? Okay, so y prime, and then we'll plug in 1. Okay. So let's kind of talk through this one more time. We're finding the slope of a function at x equals 1. We know since it's only 1 point, we're thinking instantaneous rate of change. We could do the long formula, okay? When we tend to call this one the formal definition. Formal definition of what? What is this the formal definition of? Oh, shoot, it's the formal definition of a derivative. Well, if the question doesn't say use the formal definition, well, I'm sure going to use a shortcut if I can. So that's how we get to this part, y prime of 1. This question, find the slope of the function at x equals 1, is really saying find the derivative, plug in 1. So let's find y prime, and then let's plug in 1, okay? So y prime 2x minus 4, sub in x equals 1, y prime of 1 equals 2 times 1 minus 4, or y prime of 1 equals negative 2. Now we predicted before we even went down this rabbit hole of all these definitions that our answer should be negative. And that blue line that we drew here has a slope of negative 2. Okay. Now, once we find the slope, let's see what else we need to find. It says write the equation of the line tangent to the curve. So now we want the equation for this blue line. So we drew it, we found the slope of it, but now we want the equation of this blue line, okay? Now, I am going to ask us not to write it as y equals mx plus b, okay? In fact, there is a different form of the equation of a line that I would like us to use. This form requires less work on your part and is also easier for me to check whether your answer is correct or not, okay? So you can't beat that. Less work on the teacher's part, but more significantly, less work on your part too, okay? So the equation that I'm going to ask us to use is this, the point slope form. And you guessed it, you need a point and you need the slope in order to fill that out, okay? And the equation looks something like this. Y minus y1 equals m parentheses x minus x1. Okay. So anytime it says write the equation of a line, I want you to follow y minus y1 equals m x minus x1. And so for part C, we know we're going to use this equation. And let's see what we can fill in. Well, do I have an x value of a point that I'm interested in? And if so, what is that x value? All right, x equals 1. So guess what? Everywhere that I see x1, I'm going to put a 1. Okay? So the x1 and the y1 are the point that you're interested in. Okay? Well, let's work our way backwards. Do we have m? Do we have the slope of the line at that point? And if so, what is it? We've got the slope, and that we got from part B, our derivative, okay? So now the only thing that we don't know is y1, okay? So y1 is the y value that goes with x1, okay? So we know that x1 is 1. How do we find the y value that goes with that? Exactly. We're going to go back to the original equation. This one all the way up here. And we're going to use to find y values. Okay. So let's see what happens. I'm going to plug in 1 everywhere I see a y. So I mean an x. Y equals 1 squared minus 4 times 1 plus 6. Okay. Y equals 1 minus 4, which is negative 3, plus 6, which is 3. Well, I've got my x1, my m, my y1. All I'm going to do is plug those numbers in. Y minus 3 equals negative 2 times x minus 1. Bam. There's your equation of that blue line. Okay. Where did the calculus come in to solving this question? Okay. The calculus part is finding the slope of the line. Okay. Finding the slope of the line. The other parts, finding the x value, well, they gave that to you. Finding the y value, we had to do a little bit of work, but it was work we knew how to do even before we walked in the class, right? We know that if we have an x value, we plug it into the function, the y value comes out, okay? So what's sort of this question is all about is tying all of those together to be able to write the equation for that blue line, okay? Now, part D looks so much the same as part C. But part C asks us to find the tangent line, okay? Part D asks us to find something different. It's asking us to find the equation of the normal line, right? So let's define what a normal line is. A normal line is perpendicular to the tangent line. Okay. A normal line is nothing more than a line that is perpendicular to the tangent line. Okay. It has to, well, it's, yeah. If you're going to say it's perpendicular, you got to know where, right? Like perpendicular to what? So they will tell you perpendicular to where. Okay. All right. So at the end of the day, I'm writing an equation of a line. So I'm going to write the same equation. Y minus y1 equals mx minus x1. All right. What can I put in for x1? 1. Perfect. What can I put in for y1? 3. Exactly, because that's what I had from my previous work, right? So it looks like so much of this stays the same. Y minus 3 equals, let's leave a space, x minus 1. Well, how then do we find our slope here? Is it -2? Can we just write the same slope again if the rest of it's the same? Oh, I see 2 competing answers. I see a 1/2 and I see a -1/2. What are our thoughts? It's the opposite sign and the reciprocal. Okay, so 1/2 or -1/2? It's just the 1/2, yeah. Okay, so if we want, we could even put a big old plus sign in here in front of there, just so we can kind of remember that it is changing the sign, right? That's okay. And here we go, that's it. That's our answer. So if you have the tangent line, the normal line equation is super straightforward. You just have to take your equation. You can keep everything else, except you're going to have an opposite sign for the slope, and you're going to take the reciprocal of the slope. All right. Does that make sense to folks? The difference between a tangent line and a normal line?
Just so this is clear, because I think I missed something. The slope of the normal is the reciprocal of the tangent line.
It is the opposite sign reciprocal.
Okay. Okay, I think I got it.
Yeah.
Thanks.
Yeah. Yeah, so that's why like the blue slope was negative. So our sort of seafoam green slope is going to be positive. And then we take the reciprocal of 2, which gives us 1/2. Okay. Yeah, there we go. Okay. All right. Last but not least, we're just going to draw some pictures so we kind of got an idea of what we're looking for. Okay. So for these kinds of questions, it's totally fine to say, like, here's your parabola. All right. We kind of already drew the picture for part E. So taking that tangent line, and it should have an equation of y minus 3 equals -2 x minus 1. Okay. So this is the equation for that line. Here's our other parabola, same point. They want to know at x equals 1. Anybody want to try and sketch that line in? What does the normal line look like? Oh, perfect. Yes, David, exactly. It's going to be a positive slope. Exactly. So I'm going to try and do my best to sketch what you have. Okay, this is going well, going well, going well. Yeah. Okay. So this line has an equation of y minus 3 equals 1/2 x minus 1. Okay. And if you put both lines on the same graph, you would see that the blue line and the seafoam green line, they meet at a 90-degree angle. Okay. All right. So folks, this brings us to the end of 3.4. And I'm sure there are some unresolved questions out there. And that is perfectly fine. Okay.